Hello and welcome everyone. My name is Andy. You all been receiving emails from me about this webinar. I'm the VP of Marketing at Saratech. Glad you joined us today. We'll be discussing the keys to speeding up tooling using additive technology. So for those of you new to Saratech, we're an engineering company focused on helping customers drastically speed up product development. We bring together industry-leading technologies and expertise to help you optimize your processes. With me today, we have Ken Shawinski. Ken is Saratech's Senior VP of Engineering Services. Again, Jack Gray is Saratech's Technical Manager of Additive Manufacturing. And our special guest, Mike Russell. Mike is the VP of Operations at Stretch Forming Corporation. Welcome, Mike. What are we going to talk about today? So in the next 30 minutes or so, we will be discussing the current state of the industry. We'll talk about fit and showcase key additive technologies and practical applications. I will also have an in-depth conversation with Mike and Ken, and we'll explore how SFC and Saratech work together to reduce tooling time from months to weeks. So at this point, I'm going to pass the presentation over to Ken Shawinski. Ken, please take it away.
Hey folks, pleasure to be with you today. Thanks so much for taking an interest here. Hopefully you can find this informative. So, from a tooling standpoint, first of all, my background, I've been in the aerospace and defense sector for over 30 years. And it's always the same thing, engineering development, then it goes into release, then it goes into production, and production requires a lot of tooling for the not only manufacturing, but the assembly of typically aircraft components. And what we've seen, and we deal with an awful lot of customers, is we've seen that roughly 30 to 50% of all aerospace OEMs, tier ones, tier twos, have some sort of tooling or prototyping that they're doing now with 3D printing. So it's a very widely adopted technology application. One might ask, well, why? Basically, cost and lead time are significantly improved. If you look at the design cycle, you've got the old tradition is you would have it get released, you would then make a tool, you would then send that tool out for fabrication. Weeks later, you get that part back. If there's a design change, which happens quite frequently, you've got to do that whole process all over. When you do 3D printing, literally it takes a couple of days to print a part. And if there's a change, again, just a couple more days to iterate that part. So you're taking typically months of lead time down to days, if not weeks of lead time. Typically, tooling is used for low volume production environments, although we have some really good technology with materials that can handle high volume production. So don't be fooled that tooling is only good for high volume production if it's manufactured in metal, because we have had some really good success. And as I mentioned, frequent design changes, that iterative process really complements it very nicely from a 3D printing standpoint. I wouldn't say that 3D printing is replacing the machining, it's really complementing it. I've got a couple of case studies that we'll talk about, and you're going to hear from Mike Russell, one of our customers from Stretch Form, talking about that process as well. All right, so when does additive manufactured tooling make sense? In my opinion, I think it makes a lot of sense in a lot of different ways. First, let's start with some pictures. The picture on the right is a stretch form block. That's how we first got involved with Stretch Forming Corporation. They had a very urgent task, and we really helped them improve lead time. You see that metal part on top? That is a hard metal piece. I think that's Inconel, if I'm not mistaken. And then you got the form block. And we did the first trial run. It worked out perfectly. The part was able to be CMM'd, and it met all the requirements. So we've had a lot of success printing stretch form blocks. The picture kind of on the lower left side is an assembly installation tool. And how this is made, the red parts are made out of a 3D printed PA12 material, but the backbone, we call it, the cross sections are made out of aluminum frame. And we use this to create an installation guide for installing a radome on top of an aircraft. The old method was you would go on top of the crown of an aircraft, you'd use a Mylar template. It would take about 2 days to get the installation drill points done properly. The way we've done this with one of our customers who's in the aircraft Wi-Fi space, literally we take this tool, one person can hold it up inside of an aircraft, and we took installation time from 2 days down to about 4 hours. So it was a really effective process to help the installation process. Again, low volume one-offs are ideal. Quick change is ideal. Metal forming, the challenges in metal forming are taken care of with the form blocks. And again, it's really the technology that we use. We look at the project, understand what it's required, and then we look at the solution around that as well. We do a lot of work with the Pacific Gas and Electric up in the Northern California area. We have done quite a number of tools with them. PG&E, what they do is they do a lot of natural gas piping, and we've developed a lot of tools that help their in-field mechanics do things safer, faster, and with a tighter tolerance. And PG&E has been one of our really good customers. It started with them saying, hey, we have a problem. We then just explored that problem, and then we said, okay, well, we can re-engineer something, and then we can 3D print the tools. And they've tested the parts, and we have proven successes of how these parts are saving time and money and improving the safety for PG&E in-field use. All right, my last slide. You might be wondering, well, how does the process work? First of all, typically we like our customers to come with what's called a problem statement. I am trying to accomplish this. We then say, okay, well, let us take a look at what you're trying to accomplish. Let's look at it from an engineering standpoint, because we have a large engineering team of about 75 to 80 of our 110 employees are engineers. And so we take a look at that project and say, okay, well, this is how we can re-engineer it. Here's the technology we're going to use. Here's the material we're going to use. Here's the geometry and what it's going to look like. And then we prepare the print and then print the parts, test the parts, validate that the design works as intended. And at the end, we have a successful project. Sometimes it might take an iterative process, but we've had a lot of first-time real success in this process. So again, a pretty simple process on how to move forward with 3D printing.
Great, thanks, Ken. So you saw the background behind it, how industries are adapting and moving forward with 3D printing technology. Now, what we're going to talk about is some of the technologies that we use at Saratech and some of the methods that we use to help customers like SFC. So Jack Gray is Saratech's technical manager of additive manufacturing, and he's a lot more technical than I am. So I'm going to let Jack talk about this part of it, where the technology comes in and the process and the methods come in. So over to you, Jack.
Thank you, Andy. Yeah, I just wanted to highlight kind of the 3 different technologies that Saratech uses in its printing farm that we have at UC Irvine. The first technology that I want to talk about is the HP MJF printing. These were used for those PG&E tools that Ken Schwinski was talking about earlier, as well as those form blocks. The real benefit of the MJF printing with HP is that you have isotropic part properties, which is very unconventional to a traditional FDM part. Isotropic means that it'll be like a metal part in the sense that it's 100% filled. Your part strengths and dimensional accuracies are equal across the board, unlike a traditional FDM print that you may be familiar with. The printing volumes, as you can see here, I have it in metric and imperial, 380 by 380 by 284, and about 15 inches by 15 inches by a little over 11 inches. So this is another example of where the HP print came out best. This was a press loading die operation for an aerospace company that we've been working with. These are 2 just male-female dies that are pressing and interacting with a metal part underneath there. Again, this starts as a flat tool template that is in a traditional press die, and this was formed on a 20-pound press. So these are taking a huge amount of load, and the part came out successfully on the first try and passed inspection within its first operation. The HP process was best for this application because of the powder-based strength that this is providing and the immense amount of weight that these tools can handle. And the second type of technology that Saratech utilizes is the Markforged fleet of printers. Markforged is known for FDM printers with continuous carbon fiber printing. What makes this unique is that it's able to use a full strand of carbon fiber weaved within the parts rather than just using a filament with infused carbon fiber. The Markforged print materials of Onyx, Onyx FR, and Onyx ESD are a nylon-based material with infused carbon fiber that is then can be reinforced with continuous carbon fiber, Kevlar, and fiberglass. Carbon fiber parts typically result in properties comparable to aluminum-grade components that we're seeing. The printing volumes for our largest machine, which is the FX20, is 525 millimeters, 400 millimeters, and 400 millimeters in metric, and then about 20 and a half by a little under 16 inches in the other 2 directions.
Hey, Jack, just one quick note here. A reader or someone watching this might think, hey, what if I have a part bigger than the print volume? We've had a lot of success taking parts, creating a lap joint in those parts, and then extending the print size that's beyond our print volume. And it's working quite well, even under pretty difficult loads.
Absolutely. And Ken, that's a great point where what separates us from other potential print shops is we're very comfortable with modifying components for the 3D printed geometries for all of these technologies that we're going to discuss here today. So if you have parts that are larger than this volume, or if you have something that you would like analyzed, that's where it's best if you send those parts over to us for us to give our technical feedback on. This example from Mark Forged was replacing another pressing die operation that the machine aluminums was taking much too long to manufacture. There was lots of complex internal geometry in here, and this part was a tenth of the cost than what the traditional manufacturing was made. The blue that you can see here, that is highlighting the Mark Forged slicing operation that is adding that continuous carbon fiber strands. That is a unique and patented Mark Forged technology that only those printers are capable of doing. And again, that results in strengths comparable to 6061 aluminum. So our last technology that we're utilizing is the Big Rep Studio printer. And this is a large scale FDM printer that functions very similar to a commercial printer, but just on a much larger scale. As you can see by the printing volume of 1,000 by 500 by 500. We've seen a lot of success here with what Ken was showing earlier with the tooling guides and assemblies for the aerospace companies, and additionally, just other trim shells and larger prototyping components that need to be in one piece that are easily machined and manufactured on. So this is a good example of a part. This is a chem mill template that was replacing the traditional fiberglass CMTs that are used. Previous ones were were very brittle, prone to breaking after one use. And this 3D printed part was reusable, could be used multiple times, and is a much more rigid and reusable structure for multiple passes that are going through. And it accelerated the manufacturing time from the previous weeks and months at times to just a few days of printing. The length of this part that you can see here is about the length of the entire print bed, which is about 1 meter. This one was 1 meter by 400 by 400. So again, takes the whole print bed, but still was able to produce a result very quickly and produce aerospace grade components off of this Kenmo template.
Right, thanks, Jack. So you saw some of the technologies highlighted here. Obviously, in a webinar, we can't go into a lot of details, but if you have any questions that want to talk in detail, feel free to contact us. So at this point, I'm going to change up the format a little bit. We're not going to sit here and just go through slides after slide after slide. I'm going to be interviewing Mike and Ken, and we're going to talk about the work that SFC and Saratech have done together and showcased in a real world example on what you can do using additive manufacturing technology. But Mike, before we get to the interview, please tell us a little bit about SFC.
Yeah, thanks, Andy. So Stretch Forming Corporation is a build-to-print contract manufacturer in the aerospace and defense sectors. We're located in Paris, California, beautiful Paris, California. We have 100,000 square feet of manufacturing on 15 acres, so we have quite a large facility. About 100 employees right now. Core manufacturing processes are tooling design manufacturing to specifically support our manufacturing processes, which are aluminum heat treat, metal forming, which includes stretch forming, hydroforming, and our machining as well. And so most of the components we make are like primary structure components for the aircraft, all very large components. So we're stretching heavy profile extrusions and machining them, large sheet metal components we stretch form and machine. And then obviously we try to provide a full turnkey component. So that includes all the paint processing, any secondary finishes, chemical milling processes, things like that. We've been in business since roughly 1960, in our current facility since 2010. And then we have all the certifications that go along with that. NADCAP for our heat treat processes, AS9100, obviously, and then all the prime approvals.
Okay, great. So let's get into the Q&A portion of this. So I'm going to be shooting questions at you, Mike and Ken. So for Mike, to set the stage, can you briefly describe SFC and the tooling challenges your team was facing before you started working with Saratech?
Yeah, absolutely. We've the last few years, I'd say the last 5 years, we've been seeing a significant amount of growth on new work, the new statement of work that we've been receiving. The challenge there is anytime you get a new statement of work, first time build, there's a lot of tooling that goes along with that. When you're receiving hundreds and hundreds of part numbers, you're going to need to design and manufacture all of the tooling to support the manufacturing processes. So that was our big challenge, right? It was this huge influx of new work and then all of the long lead time required to manufacture all that tooling.
All right. And then Ken, from an engineering services perspective, how common are these tooling challenges across aerospace and defense manufacturers?
Well, almost every part that we encounter that's put on an aircraft or on a car or any type of part really requires tooling and requires manufacturing, right? So the tooling needs are very pervasive. There's typically a lot of cost and lead time associated with that and the churn like we spoke about. So it's a very common problem. And we've seen those customers or companies that have adopted the technology are really starting to accelerate their business.
All right. Yeah, I mean, I totally agree with you. We're seeing this all over the industry. So, Mike, specifically, what pushed you to consider alternatives to traditional tooling methods? What was was there a breaking point that you guys say, hey, we need to look at alternatives?
Yeah, thanks, Andy. Yeah, so there was a specific breaking point for us is to kind of consider the alternative manufacturing methods for tooling. We'd run into Ken at the Paris Air Show, and he kind of had presented the fact that you guys were already developing some hydroform tooling for the industry that was additive. And when we got back to the shop, back from that trip, we had a very successful trip up there. When we got back, we actually got slammed with a huge award on the B-52 nacelle program. And we weren't quite expecting to receive the volume of part numbers we got on that program. And since it was a test development program, the timeline for delivery was extremely aggressive. A lot of the components in that package actually fit into the printer size you guys have. So we said, hey, I think we should try this and see what we can do, because with the volume of part numbers, we weren't going to be able to meet the delivery schedule the customer imposed on us.
All right. So Ken, looking back at when we first started working with SFC, so when you first look at their tooling needs, what made additive manufacturing a good fit? And where did it not make sense?
Yeah, I mean, first of all, Mike's right. We met him at a Paris Air Show. Instantly liked these people, great folks. We went to visit them in the shop. They had a lot of great capability, and they were very open to trying to find ways to improve the customer experience for their customer. And we looked at, okay, what does the geometry look like? What does the surface profile look like? What does the heat look like? What are the load requirements? And it all fit in perfectly to what we can do. And Mike was smart enough to say, yeah, let's give it a shot. We printed the first part, designed it, worked out very well. And he said, dude, let's do it. And that was really just a great start to a very solid relationship we've had with Mike and the team out there. Really, really good folks. And they're always finding ways to improve the business.
All right, so back to you, Mike. When you first saw the 3D printing forming tool delivered, in just a few days, what concerns were immediately put to rest for you? Were there any doubt?
Yeah, so I mean, the obvious concerns are is we put a lot of stress on the tool when we're forming on it. So the first thing that we had concerns of were the actual durability or the strength of the tool. Would it be able to hold up to the forming pressures we apply to it? And then additionally, we're using that tool to form a net contour. So the dimensional accuracy of the tool is a concern as well. But obviously, after we get that first tool, we went through our forming trial process and inspected the tool prior to and post forming, and noticed that there was no deflection of the tool or any deformation on the tool. We achieved the first part, first try.
Good to hear. What engineering decisions or design considerations were critical to making sure that first tool performed like traditional one?
Yeah, I think the most important aspect is to understand it from an engineering standpoint. Is there any spring back required? Are we designing to nominal? Are we designing to maximum material condition? What are we designing to? What's the end result going to look like, and how are we going to use it? Once we get that basic foundation understood, it's a relatively easy design task. And then of course, to print it, it's also a relatively easy task. So it's really taking the time to understand what the application is going to be, and then engineering it to that application.
Okay. Yeah, I mean, it makes complete sense, right? So Mike, back to you. Producing 22 form tools in about 2 months is a huge shift for SFC and for your business, right? What did that kind of lead time reduction unlock for your company and your operation?
So it did a couple things for us. First of all, we took a look at it, and essentially our typical manufacturing lead time for a tool through the standard flow process. You design the tool, you create a manufacturing planning, you create a bill of materials, you're ordering all those raw materials, bringing them in, NC programming, machining, assembly, and then final inspection of that's roughly about 10 weeks is what we estimate that. And it varies from tool to tool based on complexity and size, but on average, these tools we're talking about was about 10-week manufacturing lead time. We reduced that whole scope of work essentially from that down to design the tool, print it, and inspect it. So we went from about 10 weeks to 1 week to produce a tool. And that was significant because it didn't only reduce the lead time for manufacturing the tool, but opened our capacity on the NC programming side and also in our machine shop where we weren't having to cut all these tools and program them. We're able just to print them overnight and open up all that capacity. So it had a significant impact to our operations as well.
Yeah, that's what we like to hear, right? Ken, from your perspective, how does reducing tooling lead time from months to days change the way our customers think about capacity and throughput?
Yeah, well, if you look at some of the large scale projects that we collectively work on, Stretch Forming Corporation, Saratech, in general, any type of aerospace development program, schedule is always critical, cost is always critical. If you look at the manufacturing space, so much time has already been allocated, and typically the manufacturing lead time shrinks. And so anytime a fabricator gets a request for a quotation, most of the schedule is gone, and they've got to find ways to improve that. And we found that this is a very effective manner to do it. And then, of course, the cost benefit is a plus. And so, you've got to have a customer like Mike and at SFC who's saying, you know what, there's a better way to do it, and this is the right way to do it. So it's just really a paradigm shift of, hey, there is different approaches, and it works. It works. And it works because we take the time to understand what the application is, right? If Mike was just to go to a print service shop and say, hey, print this, it might not work because the thought process hadn't been put into that whole entire effort. So again, it comes to getting alignment to what the requirements are, and then having both parties fully aligned in terms of the commercial issues and alignment of what the end result's going to look like.
Okay. Now, Mike, for having gone through this process, so for other aerospace manufacturers watching today, what mindset shift was required to trust additive tooling in production?
I think two things. I mean, having a trusted partner like Saratech that's had some experience with doing this and being able to kind of guide us was a key thing. The other thing is just kind of taking a chance and going and taking one project and doing a proof of concept, right? Prove it out, and I guarantee you, if you do that, you're going to see an ROI.
And then for Ken, obviously, for companies that have not done this before and want to start exploring additive tooling, what's your recommendation? What's the smartest way to do it without disrupting existing processes?
From our perspective, we deal with an awful lot of customers. A customer, all they need to do is pick up the phone or email us. We'll jump on a phone call with them. They don't need to create a defined statement of work. They just need to jump on the phone and say, hey, this is what I'm thinking. What do you guys think about it? And we can very quickly come up with a yes, no, kind of no-go decision. And typically, we do find a way to work with them. Because there's an engineering piece, there's a technology piece, there's a 3D print piece. But I would say, look, if you've got some challenges in your business, come talk to us. I'm almost certain we can help out. And as Mike said, the ROI most likely will be there. And this is why we do it, right? To improve the operation of our business.
All right, thanks. And so to close out the Q&A, Mike, what's the biggest benefit SFC gained from this shift to additive tooling?
I'd say one of the biggest benefit is allowing us to be more competitive on lead times when we're putting our proposals together. We've one thing work doing this. We have about 400 tool sets in work right now that are all going to be additive instead of the traditional manufacturing process for the tooling. So it's allowed us to be very competitive. But then again, at the same time, not only capturing more work, we're able to free up the capacity in our NC programming and machine shop for other work. It's increasing our capacity and also allowing us to capture new work.
Glad to hear it. And then Ken, final quick hit for you. What's the biggest mistake manufacturers should avoid when adopting additive tooling?
I would say thinking that in their minds without exploring it, that it's not going to work. Meaning that having a closed mind to say, you know what, this is how we've done it all the time. We're going to continue to do it that way. And I'm going to answer that last question as well with Mike. For us, the benefit in working with SFC is, number one, they're great people. They have a great company. We have offloaded work to them, and we are continuing to expand the relationship. right? So they came to us first. We solved their problem. We're giving them work. We're looking at much larger work packages together, and we love that kind of collaboration. We're in it for the long haul with our customers. We absolutely love working with our customers.
That's a great mindset, right? We're a partnership. We're just here. We're just not here to sell you something and then move on. We're here to form that partnership and create business for both companies.
Yep, exactly.
In summary, if you have not thought about using 3D printing for tooling or otherwise, or you are using it today but not sure if you're getting the most out of it, talk to us. Like Ken said before, just reach out, give us a call, shoot us an email. The data has proven that 3D printing drastically speeds up production while at the same time reducing costs. So don't fall behind. Mike and Ken, any last words before we log off?
I appreciate the opportunity to be able to participate in this event.
Mike, thank you very much for attending. We didn't even pay you for this, but thank you.
Well, thank you everyone for joining us today. Again, my big thanks to Mike Russell. I know your time is very valuable and you're a very busy person. So glad you are able to join us for 30 minutes and kind of share your thoughts and ideas. But thank you everyone for joining us today, and we'll talk to you soon. Thanks.